In this video, we're going to talk about how we can combine multiple capacitors into a single equivalent capacitance. In general, what we're going to see is that capacitors are going to combine opposite to how resistors combined. So if we have a bunch of capacitors in parallel, we're just going to add the values of the individual capacitances, in this case C1, C2, and C3, to get our equivalent capacitance. So what we would have in this case is we would have one equivalent capacitance, CEQ, which is our representation of these three parallel plate capacitors. We're not going to go into details about the physical reasons for that, but if you think about our initial capacitor equation where we said C is equal to some permittivity times area divided by D, well, here we're basically adding more plate area because we have all of these capacitors in parallel, which effectively increases our equivalent capacitance. If, on the other hand, we have capacitors that are connected in series, again, they're going to combine opposite to how we combined resistors. So our series capacitors are going to combine just like parallel resistors. So we have this equation of the sum of the reciprocals, and then we inverse that to get our CEQ. If we just have two capacitors in series, we can use an equation similar to the quote-unquote shortcut equation, where we do the product of the two capacitors divided by the sum of the two capacitances.